This is Algebra 2, Unit 9, Lesson 3 on solving quadratic equations with complex solutions. Now, we just worked on the quadratic equation, and the roots or zeros of any quadratic equation can be found using the quadratic formula. So it's very important that you know this formula, because any root or zero can be found using the quadratic formula. Since this formula contains the square root, it is fair to investigate solutions to quadratic equations now when the quantity b squared minus 4ac, which is called the discriminant, is negative. Up to this point, we would have concluded that if the discriminant was negative, the quadratic had no real solutions. But now it can have complex solutions. So you can have the a plus bi in there. Now, we're going to use the quadratic formula to find all the solutions to the following equation and express your answers in simplest a plus bi form. So that's telling us that when you solve this, it's not going to factor, and you're going to have a negative under the square root. So let's try this out. All right, x squared minus 4x plus 29 equals 0. If I want to find the solutions, first it's equal to 0. Figure out your a, b, and c. All right, a is going to be 1, b is going to be negative 4, c is going to be 29. All right, so your formula is x equals negative b, negative 4 would be positive 4, plus or minus the square root of b squared, negative 4 squared, minus 4 ac would be 1 times 29, all over 2a, which would be 2 times 1. All right, so 4 plus or minus the square root of, now this I can put in my calculator what's under the radical, so it would be parenthesis negative 4 squared, make sure it's in parentheses because it won't square the negative otherwise, minus 4 times 1 times 29. And that gives me negative 100. So if I flip back here, this is negative 100 all over 2. Okay, now we can simplify negative 100 because remember, if this is complex, if it's negative under the radical, it's going to be square root of negative 1 is I. So this is actually the square root of 100 times the square root of negative 1. So this is actually going to be 10i all over 2. Okay, now the 2 is going to divide both of these terms. So that gives me x equals 4 over 2 plus or minus 10i over 2. So that gives me 2 plus or minus 5i. And that would be my roots. 2 plus or minus 5i. As long as our solutions can include complex numbers, any quadratic equation can be solved for 2 roots. Remember, this is really 2 plus 5i and 2 minus 5i. All right, now let's solve each of the following quadratic equations. Express your answers in simplest a plus bi form. All right, so quadratic equation, because it has a square root in it, which means before we solve it, it has to be equal to 0. So we minus the 7x, add the 10. Minus the 7x, add the 10. That gives me x squared minus 12x plus 40 equals 0. All right, now I can tell this doesn't factor anyway, so when I work this out, I'm going to use my a, b, and c. A is going to be 1, b is negative 12, c is 40. All right, so using my formula, negative b would be positive 12, plus or minus the square root of b squared, negative 12 squared, minus 4ac would be 4 times 1 times 40, all over 2 times 1. So that's 12 plus or minus. If I put this in my calculator, it's going to be parenthesis negative 12 squared minus 4 times 1 times 40. 4 times 1 times 40. Notice it's all in parentheses. Gives me negative 16. So if I flip back here, this is going to be negative 16 all over 2. Okay, so what's the square root of negative 16? Well, remember it's 16 times negative 1. The square root of 16 is 4. The square root of negative 1 is I. So it's going to be 12 plus or minus 4i over 2. Split it into separate fractions so you can reduce it. 12 over 2 plus or minus 4i over 2. So that is equal to 6 plus or minus 2i. There we go. All right. Let's try the next one. x squared plus 16x plus 15 equals 10x plus 4. First of all, get it equal to 0. Minus the 10x minus the 4. Watch your signs. That gives me x squared plus 6x plus 11 is equal to 0. Okay, so my a, b, and c. A is going to be 1, b is going to be 6, c is going to be 11. X equals negative b would be negative 6, plus or minus the square root of b squared would be 6 squared, minus 4 times 1 times 11, all over 2 times 1. So negative 6 plus or minus. I'm going to get my calculator out. 6 squared minus 4 times 1 times 11. All right, and that gives me negative 8. So 6 plus or minus negative 8 over 2. All right, and now I need to simplify the square root of negative 8. Well, remember, it's 8 is 4 times 2, and then it's times square root of negative 1, which would be I. So this is going to be 2I, because square root of 4 is 2, square root of negative 1 is I, times the square root of 2, all over 2. Okay, we're going to simplify this by dividing both of these by 2. Negative 6 over 2, plus or minus 2I radical 2 over 2. All right, so that gives me negative 6 over 2 is 3, plus or minus. Now, the rational part of this 2 here, can divide this 2 here, but it can't divide under the radical. You can divide a rational by a rational, but you can't divide an irrational by a rational. So the 2 out here you can divide. So this is just going to be written as I radical 2. So x is equal to 3 plus or minus I radical 2. So what we're going to look at now is the relationship between the x-intercepts and what happens when you get a complex solution. All right, so consider the parabola whose equation is y equals x squared minus 6x plus 13. Algebraically, find the x-intercepts of the parabola, express your answers in simplest a plus bi form. Okay, so if I want to find the zeros, the x-intercepts, that means that y is going to equal 0. So if I set this equal to 0, we get x squared minus 6x plus 13 is equal to 0. So my a value is going to be 1, b is going to be negative 6, c is going to be 13. Now, x equals negative b would be positive 6, plus or minus the square root of b squared, negative 6 squared, minus 4ac would be 4 times 1 times 13, all over 2 times 1. All right, so putting this in my calculator would be negative 6 squared minus 4 times 1 times 13. And that gives me negative 16. So the square root of negative 16 all over 2. Okay, now we know the square root of negative 16 is 16 times negative 1. So this is going to be 6 plus or minus 4i over 2. Split them up. 6 over 2 plus or minus 4i over 2. And that gives me an answer of x equals 3 plus or minus 2i. Okay. From your answers to A and B, what can be said about parabolas whose zeros are complex roots with non-zero imaginary parts? Okay, so this ends up as being 3 plus or minus 2i. So what can we say about the parabola? The parabola will not cross the x-axis. So it will not have any x-intercepts. Okay, so let's prove this. All right, use your calculator, sketch a graph of the parabola on the axes below, use the window indicated. All right, so let's reset my window. Okay, my window is going to be for the x's from negative 5 to 10. And my y's are from negative 5 to 20. All right, and then I need to go to my y equals and enter the equation. Let me clear this out. We have x squared minus 6x plus 13. Okay, there's my equation. I've set my window, so let's look what the graph looks like. Oh, that's a table, sorry. Here's the graph. Okay, so there's my graph. All right, so if I want to sketch my graph on here, notice it does not cross the x-axis. But where does it cross the y-axis? Well, it crosses the y-axis right here. This is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we should know that because, remember, this value is the y-intercept. The c value is the y-intercept. So my graph actually goes like this. You can draw it neatly, somewhat neatly. It's going to go up like this and come around like this. This is going to be at 13, but it does not cross the x-axis. Okay, now, having to use the quadratic formula and then figuring out that it doesn't have any roots can be kind of messy and takes up a lot of time. So how do we recognize whether or not, just by doing part of the equation, the quadratic equation, that a function has no x-intercepts? Well, we can look at what's called the discriminant. We talked a little about that earlier. The discriminant is the part of the equation under the square root. That's the b squared minus 4ac in the quadratic formula. Now, when we had complex root, what kind of numbers did you get underneath the square root? When you did the b squared minus 4ac, how did you know you had complex numbers? Well, if what was under here was negative, that means you're going to have complex roots, and it also means there will have no x-intercepts. So if we can use the discriminant and just figure out the b squared minus 4ac without having to do the whole quadratic formula, we can know immediately whether or not this is going to cross the x-axis. So let me use b squared minus 4ac. b squared minus 4ac. If this turns out to be negative, if it's less than 0, then it will not have any x-intercepts. So b is going to be negative 3 squared minus 4 times 1 times negative 10. All right, so negative 3 squared is 9, minus 4 times 1 times negative 10 is 40. 9 plus 40 is 49. All right, so will that have x-intercepts? Yes, because that's a positive number. All right, so b squared minus 4ac is greater than or equal to 0. Okay, let's try this one. If we did b squared, it's going to be 6 squared minus 4 times 1 times 10. This is going to be 36 minus 40, which is negative 4. So is this going to have x-intercepts? No. b squared minus 4ac is less than 0. So that is not going to have any x-intercepts. If I were to graph this, it will not cross the x-axis. This one will not. All right, let's try this one. b squared minus 4ac. b squared would be 3 squared minus 4 times 2 times 5. This is going to be 9 minus 40, which is negative 36. Well, that's going to be a negative, so is it going to have any x-intercepts? No, it will not, because b squared minus 4ac is less than 0. So if your b squared minus 4ac is less than 0, you immediately know that it's going to have imaginary complex roots and is not going to cross the x-axis. All right, so let's save exercise 5 right here. Try this out, see if you can figure out which one will not cross the x-axis using the discriminant. So try using b squared minus 4ac.